This is certainly a trick question, and if you want to attempt it, pause this video, try to attempt it and give me the answer in the comment box. So this question states, I hope everyone has attempted it. This question states that a boat can travel at a speed of 3 meters per second in still water, and boatman wants to cross the river in the shortest possible distance. Okay, this we have already done in past, and we have remembered the derivation as well, we have remembered the result as well. But that result was when the river velocity was, or water velocity was, less than the boat velocity, because we actually studied that the resultant will be in the direction, shortest distance is if the man reaches the opposite end or the boat reaches just the opposite end, and therefore the resultant velocity should be in this particular direction. But for this to happen, the river velocity has to be less than the boat or the man velocity. But here in this case, the river velocity is greater than the velocity of the boat in still with respect to the river or still water. Okay, so this is greater, so obviously the resultant will never lie in this particular direction, and it will never actually flow in this direction. So another approach is we try to find the resultant, we'll find the distance, and then we will differentiate this whole thing. So this let's say this is the width d, and we'll actually differentiate the whole thing and get the answer. So that is one conventional method most of you must be tempted to attempt. I have a very unique solution for this particular problem. So as I have been stating about vectors, it makes things much easier if you understand it properly. So just imagine a man traveling with a speed of 3 meters per second. So what are all the possible directions? So from the end of the river, if a man tries to travel with a speed of 3 meters per second, then all possible directions will form a semicircle, because the locus of all possible direction will form a semicircle, right? Because he can travel in this direction, he can travel in this direction, he can travel in this direction, he can travel in this direction. So all possible directions will make this case of a semicircle. So the locus will be semicircle. But what is happening? River is moving all the possible. So let us imagine that if a man was here, the river will pull this by 4 meters per second. So if this was 3 meters per second, the resultant will, this point where actually you would have reached in some time, he will not reach this point, but he will move by in the similar time, he will move by 4 into t. So if he actually wanted to move 3t as a distance, he will move 4t in this particular direction. 4t is in the same time, the net displacement will be 1 meter towards, if there is in 1 second, 1 meter towards the right. Okay, so that is how the man will move, or all the possible points will move. So what will be the final locus when all points will be moved by the river with 4 meters per second? It will again be a semicircle. It will again be a semicircle. So let me just draw that, because all possible points which is moved by the river, so it is also a semicircle. Man wanted to start from here, and therefore this point has moved by this point has moved. Okay, so man wanted to start over here, this point also moved by 4 towards the right. Now just imagine what will happen is, so man can actually this is the velocity of the man, all possible directions. So when will, so, and this was the river velocity. Okay, this is VR, river velocity. So when will actually shortest possible distance be attained? When actually this starting point will, or the resultant will make a tangential. So wherever the resultant will make a tangential, and this is what we have been talking about earlier also, then when resultant will be in the perpendicular direction, or it is tangential to this semicircular curve, or it will make the greatest angle at this, in this direction, the man will achieve the shortest possible distance, and therefore this can easily be calculated because we know this river velocity as 4, this man velocity is 3, and clearly I can actually calculate this particular thing, which is 4 4s are 16 minus 9, and 16 minus 9 is 7, so root 7 meter per second. So this I will get the angle, and if I get the angle I will get the shortest possible distance as well. So basically if I get this angle, resultant angle, I will get the shortest possible distance. So a boatman wants to, in what direction should he do? So only direction has to be calculated, so it's easier, tan alpha, and if this width is given you can calculate the distance as well. So tan alpha, so this is perpendicular, so tan alpha is always base upon so perpendicular upon base. So whenever this is alpha, this is perpendicular, this is base, so tan alpha is perpendicular upon base, and therefore it will be 3 by 4, and this is your answer. So tan alpha is equal to 3 by 4. I hope you like the solution. If you have liked the solution, give me a thumbs up and share it with as many friends as possible, because I will be talking about unique solutions. And if you have understood it, please write in the comment box. If you have not understood it, please write in the comment box, and try to think why I'm trying to do it in this particular direction, because this makes much easier. And you can think it in other ways as well, that this is the river velocity, and we have been talking about this vector, right? And this is resultant, and when Vm is fixed, right? So this is fixed, the direction is not fixed. So in which direction should he steer so that shortest possible distance is achieved is when these two things, resultant will make a perpendicular with the Vm. So this resultant, when it will make perpendicular to Vm, it will actually give me the shortest possible direction, or in this direction shortest possible distance will be achieved, right? And when this was, so basically when river velocity was less than, so obviously the locus lied inside, and therefore the only possible way is perpendicular direction, and therefore we got perpendicular direction as the direction of the resultant, because then for the semicircle the resultant will always be perpendicular at the starting point itself. Okay, so that is how we got in our first case as well. So you can try to think on these lines and try to attempt this question again. All the very best with learning high level physics and enjoying physics with me.